Hello and welcome to the channel, and a lovely sunny Sunday afternoon here in the UK. We're mid-May. Regulars to the channel will remember I built a vertical 15 metre dipole which I've used on the back of the car, and you can use it anywhere on a fence, on a pole at home, anything really. A good portable or home antenna. The 15 metre was just shy of the limits of my pole, my DX Commander Expedition pole. So what I'm going to try and do today is see what the measurements are for a 20 metre antenna. So it's a sleeveless sleeve dipole in smaller VHF form. These are known as flower pot antennas, but effectively it's not a flower pot when it's on a HF, it's quite long. So I've got some RG58 on the last legs of my RG58. It's done many a project. Just some mains flex which I'll use for the tip of the antenna, and a ferrite for a choke, and that's a key part of the design of the antenna. So I'll just explain how a sleeveless sleeve dipole works. So a standard dipole, which I'm sure you're all aware, is a quarter wave each side, fed from the centre. We can turn that on its side. So very simple transition, but you can see here the problem now is how do you feed it from its side. So a sleeve dipole is where we take the feed and run it down and away to the radio, and again you can see there's probably some problems with that. The radiation from this element is going to be going straight at the coax, and so on. So a sleeveless sleeve dipole utilises the properties of common mode currents. So effectively that is your dipole. Imagine there two equal halves. This is your coax. So the top half of the dipole is the exposed piece of coax, and the bottom half of the dipole is the outer braid of this bottom piece of coax, and that's where the ferrite choke defines the bottom of the coax. So RF goes up there and RF spills out and comes down here, down the coax, but gets blocked by the choke, either the ferrite or the coils. So it's the same effectively as that, but we're using the properties of common mode currents in a good way this time, to use that one single piece of coax. So that's the difference between a dipole, a vertical dipole, a sleeve dipole, and a sleeveless sleeve dipole. So I'm basing this 20 metre antenna on my successful 15 metre version. So here's the calculations I used then. 15 metres, effectively the part of the band I'm interested in to send it on is 21.3 megahertz. That's the voice section. If you do your wavelength frequency calculation, that comes out at 14.074. So interesting, it's not exactly 15 metres. Now the antenna that I eventually tuned was 45.9% of that measure, which comes as a total length of 6.46 metres. So that's 3.23 each half. So on that dipole model, the top half is 3.23 and the bottom half is 3.23. So to transpose that over to 20 metres. So 20 metres we're aiming for 14.250 megahertz. And if we do a calculation on that, that comes out at 21.038 metres long. But again, on this antenna, I'm going to use the same ratio because we're similar sort of frequencies and wavelengths at this part of the HF spectrum. So 45.9% of 21.038 is a total length of 9.65 metres, or two halves of 4.825 metres. Now I might increase that slightly just to allow for error and placement of the antenna. As you'll see, the 20 metre is going to be lower than the 15 metre when it comes to mounting. so there might be some ground effect. So you can see how the calculation transposed. So this antenna is going to be 9.65 thereabouts long. I was being a bit optimistic with that roll of RG58. This is a new roll, and before we get to measuring it out on the drive, what I've done is unwound some, so I've got enough to get from the base of the antenna, if it's on the back of the car, up to the coax point there on the top. And likewise, if you've got a pole in the garden, on a fence post or on a pole, this is with a bit you've got to take some interest in how long do you want this fly lead to be. So on here is going to be my choke, so that's where I'm going to start my choke, and it's going to be 12 turns. We've done this before, 12 turns around this ferrite. It's a type 43, which is great for the middle HF bands. I've got a diagram somewhere if I dig it out. Apologies for the printout. So we're going for 12 turns of RG58 on a type 43, and just to understand that this green is good, dark green is better, dark green with black is even better. So even these are the bands, and we're going for 14 megahertz, so we're spot on. And my thanks to Steve G3TXQ, who's now a silent key, for this research. So I'm going to wind the choke and then start on the antenna from there. So the cable tie just to hold it while you're putting the coax through the centre of the choke. Each pass through the centre is a turn, so there's 5. I'm going to do one more and pass it through and out the other side, and then that'll be number 6, and then finish off. So you'll see the end in a second. So here we are, finished choke. The coax is still attached to the reel. That's going to be the antenna end. There's my fly lead down for the PL plug when it gets fitted. That mark to where I started was a metre, so that gives you a good guide. You need a metre of coax to make 12 turns of RG58 around this size ferrite. So you can see there the turns: 1, 2, 3, 4, 5, 6 is the one through the middle, 7, 8, 9, 10, 11, 12, and out again. I'm going to experiment with this, and I do prefer ferrite chokes, but you could make an air wound choke. I've got one, where is it? I've got one here. This is an air wound choke. That's on a 4 1/4 inch former, so that inside diameter is 4 1/4 inches, like a paint tin or something. That's for 10 metres. A 20 metre choke in that design, so coax only, is 15 turns of RG58 round a 4 1/4 inch former. Not as good a choking quality as that, but it'll work for 20 metres. So choke made, it's time to measure up the antenna. I've changed tack on this slightly. I was going to use single core flex for the top of the antenna and coax for the bottom. I've previously used all coax, and the reason I'm changing my plan is because you've got to effectively connect this single core to the centre of the RG58. Now that's quite fine, getting that onto that and making sure it's mechanically sound to withstand use is quite an ask, I think. So I'm not going to use that. I'm just going to use a full coax design. So basically I've got to measure this. I'm going to go for 4.85 both halves, so I need two lengths of that, and mark it in the centre at 4.85 from the choke, and that's where I bear off this outer sheath and the braid, leaving the inner conductor and its protective cover in place. So just like the 15 metre one, we'll do this now. So first thing to do, measure 4.85, make a mark on the coax so I know where the middle is, make another 4.85 measure, make the cut, and then go from there. So there's the choke. The fly leads that way, ready for the PL. The full roller coax is that way, so I'm going to go 4.85, make a mark, and then measure again, same distance, and make a cut. So 4.85 is the centre of that tape, and then I'll measure another 4.85 and cut the coax. This is my second run of 4.85. If you have a long enough tape and a long enough drive, you can do this in a wanna, but I don't. So I'm going to cut this coax there, and then that's the first part done. So this is the middle marker, chokes down there on the drive, the loose tips there, And this is unfortunately where the waste comes in, because now you cut that outer sheath and the braid and remove it all the way to the tip. So you just leave the inner conductor and its protective sheet, the insulator inside, as the tip of the antenna. So I'm going to cut this carefully at its centre and then strip off all the braid. So this is what you end up with, a load of plastic outer sheath, some braid. I'm sure you'll find a use of that, and this is what it looks like. So on the centre of the tape I bared off the outer sheath, bared off the braid and stripped it all down. Be careful, because obviously the core's quite thin, so you're not yanking it off. I went down the sheath with a knife, peeled that off, then trim the braid carefully there, and you can shimmy it up and it eventually all comes off. So that's effectively the beginnings of the test antenna. So we've got coax base, coax centre top, so that's half and half, going down to the choke down there. So I need a PL259 on now, and we can start some tests with a pole. Let's see how this tunes up or not. So here's my DX Commander Expedition pole. The choke is at the base, effectively on the floor, if that was the floor, and you can see we're at this end, and there's the tip. I'm just a little bit over the tip. So my first tests, I think I'm going to try it with the choke on the floor, just to see how it works actually, and then maybe raise it up, or even extend the pole, just lash something else just to give it a bit more length on this. I'm just experimenting at the moment, so we'll see how this works. Right, you join me live, as they say. I've lashed the pole to the wheelie bin. There's the antenna with a little bit of tip folded over. Now in theory this should be a little bit long based on the 15 metre version, but in this case the antenna is actually resting on the floor. The 15 metre version, when it's on the back of the car, that choke is about there, about say a metre off the top of the car. So this could be an interesting one. So here we go. So we've got the analyser connected to the coax, power on, 10 metres, so we want 14 megahertz. So we're looking for about 14.2 megahertz, or wherever the dip is. So we're going up. You see SWR 12, 13 megahertz. He's 14, coming up now. So about 2.7. Is there a dip? It doesn't look like it, does it? So looking for the dip on here. If I go past and back and past and back, about, I saw 2.5 there. So we're just below the 20 metre band, so it's a little bit long. Fair enough, it is. So if I go back up to 14.2, and that 2.5 goes up to 2.7. So it'd be interesting to raise this off the floor somehow and see how this works. I'm only limited by the length of my pole. I could lash, just for experimental purposes, I could lash another pole on and I've lost focus now. Lash another pole on and just raise that up just to see how it performs on a longer pole. Right, I'm going to have a think. Right, Callum, if you're watching, look away now. I've extended the expedition pole by 2 metres. I've attached another 6 metre fiberglass pole to a reasonable thickness piece of the base pole, just for experimentation purposes. So I've got another 2.5 metres that way, so the choke should be about 2.5 metres off the end. I've left a little bit flapping on the end, but just a tiny bit that can support itself. Right, it's a bit blowy. Choke's there now. It's flexing a bit. I should have maybe moved the cars, but here goes. I'll be quick. Right, where's the dip? So we're down to 2.1 now. 2.1 4 to 14, yeah. So you can see the resonance has stayed about the same, but the SWR has dropped a bit. Right, so that's the first test. I'm just going to take it down, it's getting a bit bluey. Well, I was going to show you some real life tests. This is the following day. The bands are dead. This is hat green. Some 2-week, 3-week signals on there. There was only one earlier. And I've got one of them down there. This is just random bits of interference. So this is literally nobody to speak to. So I'm gonna have to twiddle my thumbs for a couple of days. I was gonna show you the antenna in action. Right, so this is MNANA, an antenna design tool. I just thought I'd show you what the antenna looks like in theory. On the grounds there's nothing happening on the bands. So 250 megahertz we want. We know yesterday on the drive it was 9.7 meters long in total, and we're going to feed it from the center. And if I show you the view and zoom out slightly, so there's the antenna on the ground, 2 meters high, fed from the center and 9.7 meters high. So we can calculate how that performs at 250 megahertz. Real ground setup. We've got no radials because it hasn't got any. We're going to put it on the ground and we're going to make it out of copper wire, and we'll calculate that. Now ignore that SWR at the moment. The tool's I think struggling a bit with the ground mounted aspect of this, but we got better than that on the drive yesterday. Far field plots omnidirectional from above, so if we took a slice through the side, we can see this is how the antennas perform. There's a big bubble of RF here with peak gain at about minus half a dBi at 25-27 degrees, and here down in the lower DX end of things where you're throwing your RF low down at the ionosphere, minus 6.7 dBi at 5 degrees. So that's a little bit down on a ground mounted vertical that does have radials. That'd be about minus 5.5, I think. So you can see with this tool, if we add some height, so yesterday we were up about 2 meters. So if I calculate again, SWR is becoming something more reasonable on the tool. Far field plot, this side view's changed, you can see quite considerably. So the peak is around 0.3 dB at about 16 degrees. And again, down this low part, 5 degrees is now minus 4.3. So we've gone from minus 6.7 to minus 4.3 just by going up 2 meters, so you can see what a difference it makes. And there's still all this RF being thrown towards the horizon here. So let's say you've got a scaffolding pole or something in the ground, you can attach it to that, a small mast. So we'll go for 6 meters high and run that again, and you can see the changing shape of the RF. So the peak is around 0.9 dBi at about 13-14 degrees, and this lower angle of radiation minus 2.7. So we've gone from minus 6.7, minus 4.3 to minus 2.7. So you can see what a difference height makes and how the antenna performs in theory. Right, you join me in the garden in the evening. There's a hint of activity on 20. So what I've done is I've lashed the antenna to this tree. It's a tulip tree if anyone's interested. So the base of the antenna is about 1.6 meters off the ground, and if I just show you what we're doing, so up it goes. There's some wire antennas up there as well, but they're in different planes, so that should be alright. So we're about 1.6 meters up, and then we've got coax run back to the rig on that chair. So the band's dropping as we speak, annoyingly. There's those little bits of interference, but they're very narrow. I've got my logbook. Golf Zero Charlie November November.
4 X-ray 6 again. Juliet Fox Mike, over. Roger, Roger. Yes, I'm using about 700 watts at the dipole 20 meter over the ground.
So here everything's a bit stronger now.
The rig is IC7.
We've got India talking to Switzerland.
Good conditions. So best ratings to India and hope to meet you again. From Basel here. Victor Uniform 3 Juliet Fox Mike, HB25 Echo Sierra Charlie. Thank you. Bye-bye. Okay, Mike. Thank you for the podcast. Thank you to you then. Good evening. Ratings here from Basel. All the best. Thank you. Bye-bye.
Golf Zero Charlie November November.
Golf Zero Charlie November November. Go ahead.
Roger Martin, thanks for returning the call. Name is Ian. You're 5'9" into the northeast England. Roger.
Roger, you're also 5'9" here in Basel from the Euro Song Contest. Go ahead.
Roger, Roger. You've been very, very busy. I've been trying for a while, but nice to get you in the end, and enjoy the pile up. And thanks for putting on a special event. 7-3.
Good. Thank you. Have a nice evening, and thank you for the short contact. Bye bye.
Japan Kilo 1 Tango Hotel Florida. Japan Kilo 1 Tango Hotel Florida. 5 and 5. 55 Josan. Over.
There's Japan.
Roger. Thank you very much for the call. Shalom. Arigato gozaimashita. Shalom from Israel. Thank you very much for the call.
Golf Zero Charlie November November.
Golf Zero Charlie November 5-5.
Roger Amir, you're 5'5" into the UK. Name is Ian. India Alpha November. Ian, Roger.
Roger. Thank you, Ian. 73. Oscar Yankee stroke 4X60T.
Well, happy with that one.
7-3 all about the VE9er, Florida, India.
Golf Zero Charlie November November.
Unit, was there a Foxtrot 4? 5 and 70 lead. Thank you, 7-3 Bon Diac, the VE9er, Foxtrot, India.
Golf Zero Charlie November November.
Was it a Golf Zero Charlie November CNN? Very good, Ian. I haven't talked to you since back in September. How are you keeping September last year?
Yeah, Roger, Russ, thanks for picking me out. Yes, nice to get you again. You're 5'9" here, peaking 5'9". I'm just testing out a new antenna in the garden, a vertical dipole, full-size vertical dipole, Roger?
Well, it's working good. The band's not in good shape. It's very noisy. So you're only like 5'6", 5'7", but I got a copy on you. It's not the greatest band today.
Roger. Well, just 100 watts from the FTDX10. This afternoon, the band was completely dead, so I've just rushed out in the garden just while it's come awake. So thanks for coming back to me, Russ. Much appreciated, Roger.
Yeah, no problem. You take care. Have a good day. All the best. The VE9er, Florida.
There's very little on the band. Slim pickings, as we say. Who that is? Echo Alpha 6 something. I'll just tune off frequency. Golf Zero Charlie November November. Roger Fernando, you're 5'5", Roger. Oh, gracias, 7-3. Oh, there you go. Echo Alpha 6 Fox Mike, Porter. Right, it's getting chilly. I don't want anything getting damp out here. So, yeah, success. it works. Right, can it be bent? I've put it on the car. The choke is just above the car, so that's 2 metres off the ground. That's exactly 2 metres. So that's 2.2 metres down, and all I've done is use a bit of string to tie it off to the car. So the actual top part of the dipole, you can see there, is bent in half. So the bottom section's straightened out and clear of the car, and the top half's bent in half. So we'll see what that does. Right, I've got the analyser precariously balanced, so bear with me if this goes a bit wobbly. So 14.2, oh, that's gone up, so where's the dip? The other way, it's gone higher. There's a dip. So they're 1.6 now at 15 megahertz, so it's the antenna is now short, but you can see how getting it above the car and above ground has changed things, and obviously that bent tip has changed things as well. So if you're adjusting your antenna, I can make this longer by just unravelling this choke a bit and letting a bit more coax up. But if you cut the base by a centimetre, you've by definition you've made the tip longer by a centimetre. So if you're cutting the base by a centimetre, you need to cut the tip by double. So if you're nibbling a centimetre off the base, the braid, you need 2 centimetres off the tip, and you can shorten and obviously lengthen the antenna if you want to add more on. So yeah, so you can bend it after all. Well, really pleased with that. It worked well on a really flat band. It wasn't even far from the ground, as you saw. Well, this antenna is going to be the basis of another project. I've got plans for it, so if you like and subscribe, ring the bell, you'll be notified when new videos are released, and you'll see what's coming next. 7-3.